So this lesson is on exponential and radical expressions. So we're basically going to figure out what happens when we put a fraction in an exponent. We know what happens when we put in a 1. We know what happens when we put in a 0. We even know what happens when we put in a negative number or a whole number, but we don't know what happens with fractions, and so that's what we're going to go over. So our goals for today are to be able to understand exponential and radical forms. We already know a lot about exponential forms. We're just going to introduce a little bit more of it, and we're going to introduce a topic called radical forms. We're going to be able to switch between exponential and radical forms, and it's not really too bad. And we're going to be able to use rules of exponents to rewrite radical expressions. So radicals. The radical symbol, which is that square root, tells us that we want the square or nth root of something. Now, a root just means something like if you're to multiply it by itself that number of times, you'll get a given number. So for example, if we were to have 2 times 2 is equal to 4, well, the square root of 4 is equal to 2, because when you take 2 and square it, you'll get 4 out. You notice the surfer, it's just because of the symbol, the radical symbol. I really liked it because it has this nice little interesting square. Was not commonly called the square root sign. You kind of have it here where you have your surfer being rooted by this wave. Let's understand our notation. So we have our n up here, our weird little square root thing, and our x. Let's go through and see what each one of these mean. So the blue thing, this symbol, is called a radical. That just is telling us what operation we're doing. The green x, that's called our radicand. Yeah, that's always called the radicand. This one is sometimes called the radical, the radix. We'll just keep it with the radical. And this n is called our index. The index tells us what kind of root we're looking for. When you see it without an index on it, we're just looking for the square root. The way that we say this is we say the nth root of x, or if it doesn't have anything, it's the square root of x. Again, we have our little thing here, our warning that if n is equal to 2, we don't have to write it, because that's just a natural thing for this symbol to work with, to find the square root. But just remember that this is just telling us what kind of root we're looking for. We'll explain that on our next slide. So what exactly is this asking? We're asking to find a number r that when raised to the nth power, so that n is the same as this index over here, so r raised to the n power is going to give us x. R is going to be our answer to this question. So we want to find out a number that when we raise it to the nth power, we're going to get this radicand. Let's do a quick check right here. We're going to identify the radicand and the index of all these expressions. Just remember that if n is equal to 2, we don't have to write it above the radical. So go ahead, pause the video, take a crack at it. Now we're going to write radicals in exponential form. So we can rewrite radicals in exponential notation. This takes a little bit of practice, so just go with it. We're going to do our best. We can use fractional exponents to make these things happen. So for example, the square root of x, we can write as x to the 1/2 power. Same thing with the cubic root of y. So you notice that the index here is 3, so we're looking for the cubic root. So the cubic root of y is equal to y to the 1/3. This works because of the product rule of exponents. We'll talk about this on our next slide. So remember what we're asking. We're trying to find a number, r, or our root, that when raised to the nth power is going to equal to x. So here, when we write it as x to the 1/2, we can use our rule of our product rule to say that when you multiply two of these things together, because remember we're raising it to a power, so we're multiplying these two together, so x to the 1/2 times x to the 1/2, that's going to be equal to x to the 1/2 plus 1/2, which is equal to x. Now both of these are actually our r. So this is our result from that square root thing. So what we're asking, is r times r. So the root times the root is going to be equal to x to the 1/2 plus 1/2, which is equal to x. So this x here is that green x that we had before. We're just asking, in this case, where we're taking a square root, we're saying if we take r, the square root, and multiply it by another square root, we're going to get the full answer, the given number that we started with. Here's another way to write it. We have the square root of x times the square root of x, and that's going to be equal to x, because we're just trying to find the two numbers that when multiplied together will give us that x. Let's rewrite these expressions here. So we have 16. We have the square root of 16. Remember, we're just rewriting it. So we have 16, and what power is it raised to? Well, it's raised to it's 1 over our index. Our index here isn't said, so it's just a squared. So 1 over 2, so it's 16 to the 1/2 power. We're going to write this one in a radical form. So we have x underneath our radical. So x is our radicand underneath our radical. And because it's raised to the 1/3 power, our index, which is our n thing over here, is on the denominator, so it becomes over here to the 3rd. Now let's take a look at the 4th root of 64. What's being asked? We're asking 64 raised to some power, so we're going to try and figure that out. Our index is 4, so we do 1 over 4, and that's how we rewrite that. So here's our next quick check. We're going to just rewrite each of these expressions. They shouldn't be too bad. Just take a few minutes and pause the video and go for it.